In this video, we will discuss factoring. Factoring is finding factors of a product. Let's first talk about the differences between a product and a factor. If we have the numerical statement 10 equals 2 times 5, 10 is considered the product while 2 and 5 are considered the factors. Factorization is the process of finding the factors if given a product. So if we're given a product of 22, then the factors would be 11 and 2. Now some numbers can have more than one set of factors, such as 12. What we will be doing is we will be looking at factoring polynomials. Now, over here, we discussed factorization of numbers, but now we're going to discuss about factorization of polynomials. You might remember how to go from the factored form to the trinomial. What we'll be doing is the opposite. If we're given the trinomial, can we find the factorization for that product? Now there are many different factoring techniques. The four I'm going to highlight today are going to be greatest common factor, grouping, trial and error, and the AC method. Please note that trial and error and the AC method are used for the same type of polynomials. So you can choose whichever one you're more comfortable with when it comes to solving the problems. Let's first talk about the greatest common factor, or GCF. If we want to find the greatest common factor, what we're looking for is the largest factor that is the same. In other words, if we look at each individual term, in this case would be 18x to the 4th y to the 9th, 45x cubed y to the 7th, and negative 15x squared y to the 5th, we're looking at what each of them have in common. If we look at their coefficients first, we have 18, 45, and negative 15. We should note that all of these are multiples of 3. Specifically, 18 is the same as 3 times 6. 45 is the same thing as 3 times, not 12, 13, no, not 13, shoot. I prepared everything else and then I can't do simple math. 15. And then this is 3 times 5. Notice that we have a common factor of 3 among the board. Now if we look at the other remaining pieces, the 6, the 15, and the 5, those don't have anything else in common. The only thing that they have in common in terms numerically would be the 3's. So I can take out, so far my GCF includes a factor of 3. Now I want to look at the x's and the y's. Now figuring out the greatest common factor when it comes to variables is actually quite simple. We look for the smallest exponent among all the terms. If we look at x's, for example, let's use the highlighter. If we use the x's, we have x to the 4th, x to the 3rd, and x squared. Among all of that, the smallest of that would be x squared, which means that all have at least x squared. That's going to be part of my GCF. So what about y? Hopefully you said that they all have at least y to the 5th. The greatest common factor, or GCF, for this particular polynomial is 3x squared y to the 5th. Now if we wanted to factor that, we would take that out and we have to write the expression that's remaining. If we divide each term, 1, 2, 3, by the greatest common factor, the remaining expression will be what's left inside the parentheses. 3 divided by 18 is 6. 4, or x to the 4th divided by x squared is going to be x squared. Y to the 9th divided by y to the 5th is going to be y to the 4th. Then we'll do the same thing with the second one, which is 15x y to the squared. And then we'll have minus 5, no x here, but we'll have y, oh, and no y there. And that's it. What this is the factorization of the original polynomial. We turned a product into factors. You might have to combine greatest common factor with some of the other techniques we'll talk about in order to factor completely. Let's talk about grouping. What we're going to do here is we're going to group factors or terms together to help us factor. If there isn't a greatest common factor among every single term, but there are common factors among some of the terms, we can group them together accordingly. And if we have the same greatest common factor, if we have the same remaining polynomial left after greatest common factor is taken out, then what we have is another common factor. Let's look here. X cubed minus x squared is 4x minus 4. Now there is no greatest common factor among every single term. They all don't have x, they all don't have 4. However, if we were to group them, say the first two terms together, and then we group the second two terms together, maybe blue would be better. Yeah. We can now find the GCF between the two groupings. For the first grouping, we're going to have x squared, which remains x minus 1. In the second one, we would have a common factor of 4, which then leaves us with x minus 1. You know what should happen if this is factorable. We should have the remaining binomial to be the same. What this means is that this is another GCF. In other words, I can now factor that piece out, and what's left is the coefficients, or the monomials, in the front here. Right there, right there. So we have x squared plus 4. This would be considered the factorization of the original product, x cubed minus x squared plus 4x minus 4. You might have to combine grouping with some of the other techniques we're talking about. You'll notice that the first one, GCF, can be used among any number of terms. Grouping is usually done with an even number of terms, grouping accordingly. You may have to rearrange some of the terms, though, to get the right factorization. The next two techniques are going to be about trinomials. So I'm going to talk two different techniques to solve the same type of problems. First one's trial and error. Just as they suggest, trial and error is simply using number sense to find the factors. Let's suppose we have 5x squared plus 18x minus 8. We know that if this is factorable, that we can find two binomials or two expressions where if we have a piece here, so I'll call this a little star, and we'll do this as a circle, and we'll do triangle, and we will do square. I know that if I were to multiply this out, I'd have to multiply these two together, this, here, and here. What we need to know is that this first term times this first term must give us that first piece. Here's where we're using number sense. If the two numbers here, or two expressions here, must give me a product of 5x squared, then my choices would have to be 5x and x. Now, if 5 was a number, say 4, we'd actually have more choices. Consequently, this also happens with the constant term. Here and here, when I multiply those two together, I must get -8. So I'm going to focus on the factors of -8 now. I can do -8 and 1, -1 and 8, -4 and 2, -2 and 4. Now, if this is factorable, then one of these combinations, a grouping from this list and a grouping from this list put together in a certain order, should give me the original product. What we have to try in the trial is determine which combination will give us the 18x. That's what we're not sure of. We know 5x squared we can get from 5x and x, and we know -8 can come from the product of any of these combinations. What we don't know is which combination will give me a positive 18x in the middle. So this is where we try. So I'm going to try a trial. Trial number 1. I'm going to go ahead and put 5x and x here, because if I multiply these two together, I'm going to get 5x squared, which is what I want. Now I'm going to pick one of these combinations. Let's go ahead and pick the first one, -8 and +1. The only thing I have to check now, does my middle terms, if I multiply 5x times 1 and -8 times x, do I get 18x in the middle? Well, 5x plus a -8x, so 5x times 1 plus -8 times x is equal to -3x. That a little better. Now, since this -3x is not the same as positive 18x, this cannot be my possible answer. I could try another trial by switching these around. Trial 2. What if I tried 5x plus 1 times x minus 8? Well, now I'm going to do my check, and I'm going to check on that middle term. 5x times -8 plus x times 1, well, that's going to give me -39x. That's not going to give me 18 either. So we're going to keep trying this until we find the right combination. There are some shortcuts that we can find while we're doing these, but eventually you should reach to the trial that you need. 5x minus 2 and x plus 4. We know this combination didn't work because we tried it. We could have still tried the other one. But if I do trial 3, which combines this combination with this combination, we should get the following. I'm going to check. 5x times 4 plus -2 times x, which is 18x. Because my middle number matches we know that this is the correct factorization for our problem. Sometimes trial and error can be really fast. Sometimes it can take a little bit of time. The more you practice this, the easier it becomes. However, there's another technique you can use to find the same answer. It's a little more procedural, but you can still find the same answer. This is known as the AC method. The AC method uses a procedure to find the answer. The reason it's called AC is because it uses the first coefficient, or the leading coefficient, and the constant. what we're going to do first is we're first going to find the product of these two numbers. Number 1, find the product of the leading coefficient and the constant. In this case, we're going to do 5 times -8, which is -40. Now we're going to, oh, it's terrible handwriting. Let's see if I do this better. I was trying to speed up the video so that way wouldn't be so long, but then I can't write as nicely. Find the product of the LC and constant. There we go. Much better. Now we're going to find factors of that product which adds to that middle term. In this case, -40 is the same thing as 20 times -2. But if I add those together, I get 18, which is the number I want. So third is we're going to rewrite. Let's go a little slower. Rewrite the middle with the found factors. In other words, my 5x squared plus 18x minus 8 is going to be rewritten as 5x squared plus 20x minus 2x minus 8. The next step would be to be factoring by grouping. Now we notice that we have, for the first two terms, we have a common 5x, and the next two terms, we have a common factor of 2. This will lead us to 5x times x plus 4 minus 2 times x plus 4. Notice how we have x plus 4 in both those. Therefore, if we go all the way up here, x plus 4 is now in common, and what we're left with as the second polynomial is 5x minus 2. Which is the same answer we got in the previous problem. Like I said, AC method is more procedure than it is trial and error. Sometimes trial and error is faster, sometimes AC is faster, but they both get the job done. We'll practice more in class.